Back pain and joint pain are two of the most common conditions affecting millions of people worldwide, ranking as the top reason for missing work and the second most frequent reason for visiting a doctor. In fact, the Center for Disease Control and Prevention says that somewhere between 70 and 85% of all people will experience back or joint pain at some point in their life. This adds up to a bill of roughly $50 billion each year. Given how widespread and costly the treatments are for these conditions, researchers and medical professionals are constantly attempting to revise and improve therapies. As part of our senior design project in the Department of Biomedical Engineering at the University of North Carolina at Chapel Hill, we're here at the School of Medicine to meet with our client about how we can make a contribution. This is Dr. Jongbae Park, Korean medical doctor, PhD, and licensed acupuncturist. He's an assistant professor in the Department of Physical Medicine and Rehabilitation at the School of Medicine, as well as the director of Asian Medicine and Acupuncture Research. He runs a clinic practicing alternative medicine and acupuncture, and among the conditions he treats, some of the most common are joint pain, back pain, and temporomandibular disorders. One of Dr. Park's methods of treatments involves the use of this pelvic balancer.
To give you a brief explanation how this works, while patients lie prone and the twisted pelvis, either right side forward or left side backward, and assuming that they lie on here, placing their pelvis, if leaving the right side, the iliac spine on here, but removing the support on the left side will make the right side pelvis move backward and left side move forward to restore the imbalance of pelvic torsion.
One of the challenges of using this device is that there's no objective measure for Dr. Park to gauge this therapy, its effectiveness, and how the patient is progressing.
How much the torsion and what level of impact that creates, and also what level of improvement my treatment made for patients was in need to measure objectively.
In order to assist Dr. Park's therapy, we sought to create an add-on to his pelvic balancer that gives him instant feedback on how his patients are laying on the device and the capability of storing that data to a computer. And our solution was this device. Our modular addition to the existing pelvic balancer consists of 6 independent pieces that house a total of 9 sensors. 1 at the head, 1 at each shoulder, 2 at each pelvic component, and 1 at each knee. Using a specialized 2-plate system of aluminum, all of the patient's weight is transferred directly to the sensors, maximizing precision and reliability. All sensors record directly through Ethernet connections to a central hub that houses the device's electronics. Everything is communicated to a computer through USB, where it can be displayed to the clinician. When I press on a cushion, in this case the headpiece, the color indicator changes in software according to the force I'm applying. This qualitative measure gives the clinician immediate feedback on how the patient is laying on the pelvic balancer. They can use this to quickly adjust the treatment. If a clinician was practicing the treatment like Dr. Park, they could enter information about the session, such as the patient ID and the date. Next, the clinician could save the quantitative force data that's displayed alongside the color indicators at any point in time. Clicking the capture button stores the information in software for later use. After collecting a few data points throughout the treatment, permanently saving the data is as simple as clicking the button marked Save. This creates a file on the desktop where the data can be accessed in an Excel spreadsheet. The clinician can use this data to track patient progress over time, as well as direct treatment in consecutive sessions. When our device is used in addition to the pelvic balancer device, the treatment becomes much more focused. Dr. Park is able to refer to software for immediate feedback and direct his treatment accordingly.
We'll be able to assist more clinicians to treat these patient population to better assess the level of musculoskeletal imbalance and evaluate their treatment effect more instantly, and therefore they can tailor the level of their treatment procedure to fit the patient's need and their conditions.
With biofeedback to guide Dr. Park's therapy, we expect the guesswork to be taken out of the treatment. The ability to monitor and analyze patient progress over time provides a valuable tool in the treatment of back pain and joint pain. We hope that our contribution will help further alleviate the symptoms of such prevalent conditions.